So my name is Jason Plurad from IBM. I'm a software developer in the open source group. I work on graph technology, so Apache TinkerPop and JanusGraph. So why am I at an HBase conference? Good question. Talking about graphs. Because we find that graphs fall alongside with other data stores. So we're going to talk today about property graphs, what they are, and a little bit about the open source graph community, and then introduce JanusGraph, a project which runs on top of HBase. So what is a graph? Graphs are not new. Obviously, they're a mathematical structure. Graph theory goes back 300 years or so. And we're finding it more and more in today's modern data architecture. What's interesting about a property graph, when I talk about a property graph, I'm talking about a label-directed multigraph. So what you have is you have vertices, which are your entities, and they're represented as circles most typically. Then you have your edges. They connect the vertices together, and these represent your relationships. On an edge, you have a label, which describes the relationship between the two nodes. And then you have the properties. You have properties on the vertices, you have properties on the edges, and you could actually have properties on the properties, which we call meta properties. So that's how what we consider a property graph model. When we started in graph, it was probably about 5 years ago, and we just started seeing graph appearing all over the place. Google was probably the biggest example of this, Google and Facebook, with the idea of a knowledge graph or a social graph. And we wanted to see how we could start applying that to our product set and our solutions within the company. One of the first projects that we worked on was a corporate social graph, an enterprise graph, if you will. We built it on top of IBM Connections, gathering all the interactions between employees on our internal network to try to drive some analytics as to how people communicate with each other and how we can drive recommendations of who you might want to speak to if you're looking for an expert in a particular area. And over the years, once you start seeing a graph in a problem, you continue seeing it in other places. And we've been able to apply the idea of a graph to other areas within the business. Most recently, I've been involved in a hackathon involving cognitive elder care, where we're taking device readings from IoT devices within a senior citizen's home, placing that into a knowledge graph, and connecting it with people in that senior citizens social network to figure out who might be able to help out as things go wrong within inside the house. So as we started down the graph space, we knew we didn't want to start from scratch. We wanted to work with the open source community as a funnel for innovation. And when we took a survey of all the popular graph databases that were out there at the time, they all started pointing back at this project called TinkerPop. TinkerPop was founded in 2009. It was originally started as a open source vendor agnostic project. And it just happened to be adopted by all the vendors at that time. So we saw that as a great win. It gave us the flexibility to try out property graphs with a variety of vendors, being able to use the same structure and query language. So as we continued working in the graph space, we worked with the TinkerPop team and brought them into open governance at the Apache Software Foundation. We went into incubation in 2015, became a top-level project in 2016. And as you can see, we're now churning at the ASF. We have over a dozen committers and I don't know how many different contributors, but it's been a great project to be involved with. Very briefly, one of the key parts of the infrastructure is the Gremlin graph traversal language. This is a domain-specific language for graphs. It gives you the ability to essentially write your queries in an agnostic way. We like to think of it as the SQL for graphs, even though there are probably many vendors who think that they have a SQL for graphs. As you can see, well, maybe you can, but I attempted to show here a very simple type of graph query where we're starting from a specific node called Gremlin and then repeating a traversal. We're going up the hierarchy tree through the manages edge all the way up to the CEO. This type of recursive query is something typical that you would find in a graph type of query. Gremlin provides probably about 50 different graph traversal steps, which appears to be a fairly full set of composable steps that you can build to do your graph traversals. The TinkerPop stack, it contains a large amount of different pieces, which makes it really great for contributions. So at the top, we got a server, we got the traversal language, which I talked about, the core API for the graph structure. Then at the very bottom is the key pieces of differentiation between a graph database for OLTP type of traversals and the graph processor for OLAP. And these are both not included in TinkerPop, and we rely on the rest of the graph landscape. And as you can see here, this contains a large set of open source packages and vendors that all implement the TinkerPop stack. This is just a brief, this isn't even the complete set. So on the left side, we have the graph databases. Neo4j is probably the most widely known graph database. We have JanusGraph, we have Stardog and BlazeGraph. They come from a RDF, semantic web graph type of background. Specifically for HBase, it's really interesting that we actually have 3 implementations here of the TinkerPop stack with JanusGraph, HGraphDB, which was written by Robert Yokota from Yammer, and then Apache S2Graph, which is out of Kakao in Korea. So lots of different options to do TinkerPop graphs, graph databases. On the OLAP side of the house, we're fully leveraging the Apache stack with Apache Spark, Hadoop, or Giraffe, being able to do that BSP type of operation. OLAP, you want to do OLAP type of operations for whole graph type of algorithms. So for example, if you wanted to run a PageRank across your graph, doing it in OLAP fashion would be the way to go. OLTP is more suited for EgoNet, egocentric type of traversals. So JanusGraph. JanusGraph started in 2012 as a project called Titan. And at that time, there was nothing in the market in the open source space that did a scalable graph that can work on a pluggable backend that also fully implemented the TinkerPop stack. The team that worked on Titan, it was a company called Aurelius. They got acquired by DataStax, which notably backs Apache Cassandra. And as they got acquired, their developers worked full-time on the DataStax enterprise graph, leaving Titan in a sore spot. So this was about 2015, and there were many companies and individuals who were using Titan at the time, and we all just basically wanted to know what we were going to do. So as time went by, we ended up meeting Misha Bruckman from Google at a MongoDB conference, and it just turned out that there are a lot of people that wanted to do graph. So we had got together. Some of our founding members are listed there: Hortonworks, IBM, Google, Xpero, and we set up JanusGraph project at the Linux Foundation so we can continue the idea of a distributed open source graph where people can come and work together on this graph database. The community started in January of this year, 2017, with those 5 companies. And now, since then, we've had 2 releases. That's actually out of date. The latest is 011. And we have other companies who've joined on board, including Amazon, Netflix, and Uber. Amazon, we'll see in our architecture slide here when we talk about JanusGraph. We have the idea of a pluggable backend, and this is an interesting piece for a lot of folks. As I mentioned before, when you have a graph, most likely you have other stores in the picture. And that's actually one of the goals that was there when JanusGraph was started, that being able to sit alongside with other distributed data stores in your stack was an important aspect. We didn't want to essentially rewrite that that architecture if it's already been invented and perfected through another project, whether it's Cassandra, HBase, or DynamoDB, as Amazon has contributed. So looking here at the architecture, we can see the red blocks. Those are coming out of TinkerPop with the Gremlin graph computer for OLAP traversals on the left, and then TinkerPop API on the right. In the center, the blue pieces in there, those are the core pieces of JanusGraph, providing the parts that TinkerPop doesn't provide around indexing, transactions, and things like that. Then at the bottom, we have our scalable backends. We break it out between storage backends and indexing backends. So on the left, notably, we have HBase and Bigtable. Now I'll introduce Jerry Hay, who is a committer on HBase, to talk about how JanusGraph interacts with it.
Thank you, Jason. Thanks, Jason, for the nice introduction to property graph, to TinkerTop, Gremlin transversal language, and also to the JanusGraph. And I'll continue with a look at the storage model and how we use HBase as a backend storage. This is a very clear. I cannot get anything better than that. It's very clear how the storage model works in JanusGraph. It's an adjacency list, and it's perfectly made for a column data store like HBase. The vertex is a key. For every vertex, you have a row in the database. The row key is the vertex ID. And then you have the relationships at the columns for that row. The relationships can be a property on that vertex. And also the edge, which is a relationship, for example, of friends, the book you read, it's a relationship. And we call that an edge for that vertex. So this is sorted by the ID, and also please note that it's also sorted by the relationship on the horizontal side. The reason that is sorted by the type and the sort ID is to make it very easy to do query transversal, because remember that we're not just trying to transverse on the vertical side. We're also trying to transverse on the horizontal side, because that is the most use case, because we're trying to find the relationship for a particular vertex. For example, the books or the movies a particular person watch or read. So that is all on the horizontal side. So hopefully that the data model we make here can facilitate that, can speed up that. And this is the edge. And we look at the entire adjacency list. And this is the edge and the property. You can see the edge is the column on the row. The column has a column name. The column name is not just the edge ID. It contains a sort key, and also the vertex is pointing to. So that is the part of the column, and the value contains the rest of the properties. So the important thing to note is that it has the label ID, which is the type of the relationship, and also the sort key. Sort key is a property on that relationship. For example, you're a friend with someone, and when did you start become a friend of that person? The time can be a sort key, because you want to put the sort key, you want to put a key, a property in the column name, so you can scan without looking at the value on the horizontal side. So that is a very important part, that the design of the column name is on purpose. Hopefully that will help the transversal on the horizontal side, because you're trying to look for the relationships. You're not trying to scan how many the person. You're trying to scan the friends of that person or the books of that the person that reads or the movies that the person has watched. So that's the way that you design the edge. And also the property is quite simple. It's the property key, the key ID, and also the property ID. The property value. You can see it's perfectly made for HBase, because that is actually how HBase works the best. So I'm going to go back to HBase. This is the HBase conference. So HBase is the perfect backend storage for JanusGraph. And it's big enough for the biggest graph. You can have millions of vertices and billions of edges, because each vertex can have a lot of relationship switches on the edges. And the storage model, we've talked about the storage model. It's just tailor-made for HBase. It's schemaless. You can add relationships, which basically you're adding columns to the row. And it's scalable. It's strong, consistent. And the last but not the least is a great open community. You can show up in the mailing list. You can show up in the Jira. If you have issues, you want to improve something, it'll show up. You show up, and you're going to get help. And this is a very simple configuration that you can do to use HBase as the backend. Give it a name, a table name, whatever table name you want to give. A table corresponds to a graph. A graph is stored as a table in HBase. So give a table name and give the regular parameters that you need to connect to HBase, which is the zookeeper address and also the zookeeper node. Those are optional. If you don't have it, go to default. And just set out the properties, and then you can just open the graph. Very simple, yes. And also you can throw in a backend, for example, Solr, a search backend to speed up the query. Again, it's configuration for connecting to a Solr instance. And a little bit more details here. The data stored into column families into HBase. You have the edge store, and you have the edge store, you have the ID store, transaction log store, and the system property stores. And you can set the column family attributes, for example, compression and TTL. So the edge store is the one that we were looking at, and also an index store. JanusGraph stored certain type of indexes inside HBase. Some of the index are utilizing the external search backend, but some of the built-in index are stored in HBase, which is part of the column family, the index store. So this is a very clear picture. You have a transversal, you have a Gremlin transversal. You're trying to find who Alex knows and the names. Basically, the transversal language is going to be optimized, translated into a query plan that goes to the backend, goes to HBase, and it goes to the index provider, for example, Solr. And it's not a lot of, it's no stats. It's basically static translation, but it's being optimized. And you have a query plan that efficiently use the index and the edge store to get your results. Okay, and this is a little more details as well. It uses get, multi-get, and uses the batch API to mutate, and doing key range scan, and using the column range filter. Remember, you're doing horizontally. You're trying to scan the columns of that row. So it is the column range filter is being pretty heavily used. HBase tuning, I don't have time to go into that. Basically, the normal rule apply. You pre-split the regions. And also, you can basically have all these client-side properties passed in from the JanusGraph side. For example, the scan caching, the scan timeout, the maximum result size, or the recently introduced allowed partial. You can all put into as a property there. Last not the least, JanusGraph support the Google Cloud Bigtable. We've been talking about in the morning the Google Cloud Table, It uses the HBase API, 1.1 API. And notice that the storage backend the name is actually HBase. So it's using the same API, but it's going a different route to the Google Cloud Table. And also, Misha Bookman is from the Google Cloud Storage Big Table team. Is being an original organizer of this project, and has been an active member in the project. A contribution from them as well. Okay, thank you.